Thank you.
Okay, thank you very much, Anna. I have to hurry up. 10 minutes is not a lot for a huge topic like group decision making. We already used this first slide, the picture of the first slide 4 years ago. We also dealt with group decision making then. And today I will present some new considerations of our institute, of our colleagues and myself in transforming AHP group decisions by combining it with fuzzy logic. So the main topic is group decision making and the AHP, of course. Considering that you usually have a number of well-informed decision makers, experts in their field, or having the knowledge to be able to evaluate the situation, you always have to consider how can we aggregate the evaluations. So there are in particular two typical ways of doing that. The first one is the aggregation of individual judgments. That's what we all know, using the geometric means method to aggregate the pairwise comparisons. In this case, the individual judgments disappear. You come to a solution, you can make a decision, but the individual opinions, they really disappear, you lose information. So another way of doing that is aggregating individual priorities. In this case, it is possible to still consider the individual situation, the individual judgments. So if we use the AHP, you have a number of decision makers. So in fact, you get a number of crisp priorities or crisp numbers of priorities for each of these decision makers, and then you can consider what to do with that. So our idea was, why don't we combine these individual priorities by using fuzzy logic and the theory behind it? So the research question is it possible to aggregate individual AHP priorities in a non-consensus decision situation? So if we have a consensus within the decision makers, no problem, because then they more or less came to the same point of their solution, and it's not difficult to evaluate the individual decisions. By transferring these crisp AHP priorities into fuzzy AHP priorities. So this was the core idea behind it. Just to get a little bit deeper into that, we wanted to show that it's possible to cover the whole spectrum of answers. It is a new approach. We also did some literature research, and to our knowledge, it differs from other aggregation procedures, like the aggregation of individual preference structures of Escobar and Moreno-Jimenez. The individual objectives of different actors are incorporated by using this fuzzy logic, and the approximation of an aggregated preference structure is therefore possible. It's not the time to go deeper into the application of the fuzzy AHP, but I think that most of you already know that there are a lot of applications available where the fuzzy analytic hierarchy process was used. Some examples you find here and also in the presentation slides, of course. So to cover the whole range of evaluation in a group decision situation, we transform our individual priorities by aggregating them using the fuzzy analogic hierarchy process. So we get, in fact, triangular fuzzy numbers. That's a simplification, of course, but it's the usual simplification where you have a lower limit, a middle value, and an upper limit. And the membership function reach, of course, from 0 to 1, where you have the left side of the number, the right side of the number, and the middle of the number. And all other values are not possible, so the membership function in this area is 0. So M1 is covering the whole spectrum of possible outcomes. I think it will get clearer if I come to the concrete example, where you have K decision makers evaluating an AHP decision hierarchy. That's what we did in our example. You get a priority vector for each of these decision makers and aggregate now these crisp evaluations into one fuzzy priority vector. By the minimum, this is the lower limit, a middle value, and of course, a maximum value. This is the upper limit of these fuzzy numbers. And of course, you have to consider the basic operation of fuzzy triangular numbers, which you see here in the formula. So let's come to the numerical example to be in time. I think it should be working. We had a panel of 8 experts, and as you heard, I'm coming from the University of Natural Resources and Life Sciences. So this is our core field of research. We are doing research on sustainability aspects in the whole supply chain of the food production. So to evaluate the sustainability of palm oil, we used an expert panel of 8 different experts. You certainly know that this is a huge topic in the food production area. We also included qualitative information based on an ISAHP hierarchy. We evaluated the criteria by pairwise comparisons because there is no literature available how important are specific aspects of this decision hierarchy. You find this here below. You have ecological, economic, and social sustainability aspects. So this is the typical representation of the sustainability term in view of the Brundtland report, if you know that. And in the end, we evaluated different alternatives: conventional palm oil, RSPO certified palm oil. This is the round table about palm oil, and as a conventional alternative, the rapeseed oil, which can also be produced in areas like Austria, where we don't have, of course, tropical or subtropical climate. The evaluation of the alternatives based on quantitative information. So this is coming from several studies. Also, some qualitative aspects are there. But just to give you an idea, the climate change, for example, is a sub-criterion of the ecological sustainability, and it is measured in tons CO2 equivalents for the production of 1 ton of palm oil. So this is a typical and usual approach in sustainability measurement, but in fact, the evaluation of the importance of the different criteria differs, of course, if we take into consideration the provenance of the different experts. So some of these experts coming from NGOs, some are coming from the food production area. So for each of these experts, the importance of different criteria changes a lot. For example, if you compare E1, this is a typically expert from an NGO, with E3, you see there's a big difference, a huge difference in the evaluation of the importance of ecological criteria in the sustainability discussion. And if we aggregate all these evaluations, we come to the point where we get this fuzzy numbers with the minimum, the medium value, and the maximum of each of these evaluations. And this can be combined to evaluate, in fact, the 3 alternatives, in our case, conventional palm oil, rapeseed oil, and RSPO certified palm oil. And what we can see from this result is that because based on the huge variety of evaluations, we get also a huge possibility that, for example, RSPO certified palm oil would be evaluated better than rapeseed oil. If we combine everything with individual judgments, the definite most sustainable alternative would be rapeseed oil.
You have 2 minutes.
Yeah, this is my last slide, so I'm really in time. So the conclusions and limitations of this study, this is only a starting point. It is an idea. It is an idea how we can handle group decisions by using a more advanced methodology of the AHP. In the presented case, there was a huge range of evaluations, and also therefore we got the result where you see that the range of evaluations is really large. Sorry. So we have a group decision which is by far not homogeneous. The assessment of sustainability is difficult. It depends on the individual position of the decision makers and their associated organizations. So it depends on if this is a company producing food or if this is an NGO trying to protect the environment. So there's a good chance that the alternative RSPO in our case would be evaluated better compared to the overall aggregation of the evaluation. So using IAJ, So aggregation of individual judgments, rapeseed oil would be the most sustainable alternative in this evaluation process. But in fact, it is not that clear if you consider the whole range of evaluations. So our goal was to visualize the heterogeneity of a group decision situation. In this case, our approach is definitely beneficial. It could also depend on if we use a different approach to combine our fuzzy numbers, but this is something it's an ongoing research process. If it's the goal to make an actual decision, which was not the goal in this case, you definitely should use the aggregation of individual judgments. So thank you very much for attention. And of course, I'm open for questions now.
Okay, thank you very much, Professor Meixner, for this presentation. If you stop presenting, for the moment, and if some of you have some questions or some comments, feedback to our presenter, now we have time, 5 minutes. I would like to open the question and answers. Please raise your hand. Where there are participants, below the participants, you have the possibility to raise your hand. Okay, there is a question from Konstantin Dektariev. See? You would like to ask our presenter?
Sorry. Yeah, the surname is a little bit complicated, so Konstantin is fine. Oliver, thank you very much for the presentation. If possible, I would like to ask the following question.
Yes, sure, do it.
You are talking about triangular membership functions.
Yes.
But it's not pretty clear why do we use them, and I will explain the question maybe in short. We don't have any information concerning the slopes. Strictly speaking, we have intervals, it's better to say. And we have the corresponding estimates, which can be called the central points of each opinion. Maybe it's a good idea to evaluate everything in terms of intervals.
Yeah, that's
interval calculations can be just an approach which can be explained much more easier than the appearance of the triangular membership functions.
I'm not sure, because I think it's not a big difficulty to explain the triangle membership functions, but you're right, we can discuss this also, or we could include it also to considering intervals. But the advantage of the triangular fuzzy numbers is, in my opinion, but this is not proved with a mathematical approach, is that you also visualize the median value, which is not automatically the median value of the triangular fuzzy number, as you see in this case. I just switched to it. You see that the left side, for example, is by far not the same interval compared to the right side of the triangular fuzzy number. But you're right, we could use intervals as well. And another question came from Elio. The variability, we also did that. We used the mean and the variance, for example. We did that. And in this case, you get a much closer, of course, triangular fuzzy numbers. This is also advantages, but you don't cover the whole range of the whole spectrum of answers. So we decided in this first approach, and this is only an idea, and that's the reason why I'm presenting it here. I want to discuss this with the scientific community, if this is a valuable approach or not, okay? So we already did that, and the results differ a little bit, of course. The triangular fuzzy numbers are getting closer, but of course, you only consider parts of the decision and not the whole range of decisions.
Dr. Meixner, you can also contact with Alessio. I don't know, Alessio, if you want to say something, because we see in the chat that he wrote that probably he developed something similar here, and he passed the information to the publication. Okay, so
I'm not sure my microphone is working. Is it working, my microphone?
Yeah, we hear you.
Oh, perfect. Yeah, yes, we had a similar idea where we take the minimum, the maximum, and the mean to define a scale. So it's a little different context, but So the idea is the same, where we define a minimum, a maximum, and a mean.
Yeah, but that's nothing new. I know that there are a number of publications available dealing with fuzzy AHP, minimum, maximum, lower limit, upper limit, and so on and so forth. Our idea was to combine or connect it to group decisions. I think that's the difference to publications like the one you mentioned. But thank you for the hint. I will have a look at that. Probably it can help us to solve or to get a little bit deeper into the topic. Thank you.